The electronic color code was developed in the early 1920s by an organization called the Radio Manufacturers Association as a standard way of marking resistors and some other electronic components such as capacitors and inductors. In this program we will focus on resistors since that is its primary use today. The advantages of color coding over printed text on physically small components are the inherent increase in marking area, which makes the values easier to read without magnification, and a 360-degree viewing angle, which cannot be achieved with text. Color-coded markings are also more resistant to abrasion. On the other hand, color degradation due to aging, oxidation, and overheating can be a problem. To read a color code is easy. The colors represent numbers. Notice that the numbers form a sequence starting with black for 0, brown for 1, red for 2, orange for 3, yellow for 4, green for 5, blue for 6, violet for 7, gray for 8, and white for 9. Notice that red, orange, yellow, green, blue, and violet are the colors of the color spectrum in order. These are the colors of a rainbow. If you can remember the colors of the rainbow, red, orange, yellow, green, blue, and violet, all you need to remember is that the numbers start with black, the absence of all color, then brown, go through the 5 colors of the rainbow, and end with gray and then white, the mixture of all colors. Another way to remember is to employ a memory aid called a mnemonic, such as big boys race are young girls, but violet generally wins. It is well known that some mnemonics are more memorable than others, but most of these variations, like the infamous Bad Boys version, are often considered inappropriate for classrooms. Other languages have other mnemonics for this color code. A rough translation of the French version is, "Don't eat anything or I'll beat you violently, big animal." Most resistors have 4 color stripes, although some, called precision resistors, have 5 bands. Reading a color code is simple. With 4-band resistors, the first and second colors represent the first 2 digits of the resistance value in ohms. The third band represents the multiplier or number of zeros after the first 2 digits. An exception to this is when the third band is silver or gold. If it is gold, the first 2 digits are multiplied by 0.1. If it is silver, the first digits are multiplied by 0.01. Resistor color codes are like scientific numbers with a mantissa and an exponent or power of 10. The fourth band on a 4-band resistor is called the tolerance band and is either gold 5% or silver 10%. Today 5% is a standard grade resistor. Let's try some examples. Here is a resistor with a color code brown, black, red, gold. The first band is brown, which is 1, the second band is black, which is 0, and the third band is red, so the code is 102. The third color, or red, represents 10 raised to the 2 power, or 100. This is the same as 2 more zeros, so we have 1000, or 1000. The fourth band is 5% tolerance, so a brown, black, red, gold resistor is 1000 ohms plus or minus 5%. Now 5% of 1000 is 50, so this resistor can have a value from 950 to 1050 ohms. Here is another resistor, yellow, violet, red, silver. Yellow is 4, violet is 7, red is 2. So this is a 4, 7, and 2 more zeros. The first 3 colors represent 4, 7, and then 2 zeros. So this is a nominal 4700 ohm resistor. The fourth band is silver, so this resistor has a tolerance of plus or minus 10%. So we have a 4700 ohm resistor with a 10% tolerance. Now 10% of 4700 is 470, so this resistor is guaranteed to be within the range of 4700 ohms plus or minus 470 ohms, or 4230 to 5170 ohms. Here is another resistor, white, violet, black, gold. White is 9, violet is 7, and black is 0. So the color code reads 970. It is a common mistake to interpret this as 970, but remember the third digit is the number of zeros, so 10 raised to the 0 power is 1. The multiplier is 1. There are no zeros appended to the digits 9 and 7, so it is just 97 ohms. The fourth band is gold, or 5%, so this is a 97 ohm resistor with a tolerance of plus or minus 5%. 5% of 97 is 4.85. If we add and subtract that from 97, That means this resistor value has to fall within the range of 92.15 to 101.85 ohms. Another example, yellow, violet, orange, gold. That is 473, or 47 with 3 zeros after it. That is 47,000 ohms, or what we would call 47 kilo ohms, or 47 K ohms for short. This resistor has a tolerance range of 47K plus or minus 5%, which equals 44,650 to 49,350 ohms. Another example, violet, green, blue, gold. This is the code 756, or 75 with 6 zeros after it. That is 75 million ohms. Or we can call it 75 mega ohms, or 75 M ohms for short. Notice the capital letter M. Here is another 4-band resistor with low valued resistance. Its colors are green, red, gold, silver. Green is 5, red is 2, gold in the third band is a multiplier of 0.1. So the code reads 520.1. And so we multiply 52 by 0.1, giving a nominal value of 5.2 ohms. The fourth band is silver, so this is 10%. 5.2 plus or minus 10% gives us a range of 4.68 to 5.72 ohms. Therefore, to be called a 5.2 ohm resistor with a tolerance of 10%, the actual value must fall between 4.68 and 5.72 ohms. To review, 4-band resistors consist of two color codes representing the first two digits of the number, followed by a multiplier, and then the tolerance band. Not all resistors have a 10 or 5% tolerance bands. Many years ago, some resistors had a 20% tolerance, which was indicated by not having a fourth color band. You might find a 3-band resistor in an antique radio or television. For most applications, 5% resistors, or 10%, is more than adequate, but some requirements a more precise resistor must be used. Precision resistors commonly use a 5-band color code. For precision resistors, the first, second, and third bands give the first 3 digits of the resistance value. The fourth band is the multiplier band. The fifth band is the tolerance band. A brown band represents a 1% tolerance, a red band 2%, a green band 0.5, blue 0.25, violet 0.1, and a gray band represents 0.05% tolerance. For example, the first 3 bands of this resistor indicate the first 3 digits, 2, 0, 0. The fourth band, the multiplier band, is brown for 1, or 10 raised to the 1 power. In other words, just 10. So we get 2, 0, 0 with another 0 after it, or 2,000 ohms as the nominal value. The fifth band is violet, indicating a tolerance of 0.1%. So this resistor has a value of 2,000 ohms plus or minus 0.1%. This resistor is guaranteed to be within 0.1% of 2,000 ohms. To calculate this, we convert 0.1% to a decimal number by dividing by 100, which gives 0.001, and multiply by 2,000 to get 2. So this resistor is guaranteed to be 2,000 plus or minus 2 ohms. It can be no less than 1998 and no greater than 2002 ohms. What has been described in this presentation is the most common ways that color codes are used on resistors. There are other uncommon variations, such as precision resistors with 6 bands, including a band after the tolerance band that indicates temperature compensation, or quality codes that are not standardized. Also, some resistors do not use color codes, but have a number printed on them. This tiny surface mount resistor has 100 printed on it. It uses the same coding system as color codes. This one is 10 with 0 zeros after it, or just 10 ohms. This surface mount resistor has 151 printed on it. That would be 15 multiplied by 10 raised to the 1 power, or 15 times 10. In other words, 15 with 10 after it, 150 ohms. Surface mount resistors are sometimes called SMT, surface mount technology, or SMD, surface mount device resistors. Surface mount technology is used in all sorts of devices which must be small in size. Large power resistors also have the resistance values printed on them. Since there is plenty of space, they are often printed without using any scientific number code. Having learned the common color codes, you will be well prepared for selecting the most common electronic component, the resistor.